So this is getting to know your data. An SPL prerequisite. SPL is the acronym used for Search Processing Language. People think it's Splunk something language. Doesn't matter. I'm Mary Cordova, and I'm going to help you figure out what's going on. I think there we go. I think that'll be better. So I've been working in security operations for nearly a decade. I started in SIM engineering with a tool called ArcSight. I've been working with Splunk for about the last 6-7 years, doing SIM-SOC, IR, analytics for InfoSec. What else is on there? SOAR. And then I've got a bunch of certifications, and I've done, you can see, various talks. We're going to talk a little bit about why you need to get to know your data before you start, building dashboards and visualizations, the process and then the method that I use. And then we can do a live demo and you can kind of see that in action, hopefully if the phone works. And then a few resources and some wrap up and questions at the end. By the way, everything I'm going to use for the live demo is publicly available. So you guys could literally get out your laptops and kind of step through the same steps with me when we get there. The talk itself is pretty fast, so I think we'll have a good maybe 30 minutes to mess around at the end if you guys want. So I'm a member of the Splunk Trust now, but how I got into the Splunk Trust was the argument that I was having on the side there with some current Splunk Trust members at the time. I had posted a question and then my own answer to that question, and the first statement was, if the data set permits. And they actually deleted my answer off of the platform because, they say there's so many unspoken caveats to if the data set permits. But in my opinion, you have to understand your data before you can do anything. So of course, every answer to every question is if the data set permits. Once you get past syntax, right, pipe, table, command, then from there it's all about, does the command you want to apply to your data give you the expected output? And that's going to be contingent on your data. In Splunk, and I think that this process and method could be platform agnostic. So if you were using something like Elk or another tool, maybe BigQuery and Looker, the process might apply. Obviously, the commands won't. In Splunk, a lot of times, there's an app or a TA, right? So you're going to monitor Linux logs. There's a Nix app that you deploy to your search head, and it does all your field extractions for you. What happens, though, all the time, and is the bane of InfoSec SIM engineers, vendors will change their schema, and then everything you built no longer works. Also, I pretty much don't ever trust anybody else, so I might go install an app or a TA, but I will go through basically the exact same process to verify that their work is the work that I would have done. There is a TA, it was a few years ago, I don't know if they fixed it, but a Cisco one built and deployed by Cisco and available on the Splunk base that was parsing network traffic so that it looked like it was in the reverse order. So all of your inbound traffic looked like outbound and vice versa, just because they had source and IP destination flipped. So, even if there is an app, even if somebody did this work for you, you might still want to go and do it again, or you might have to do it later anyways when somebody changes something. So here's the process that I use. It's 3 main components. Data preparation. This is going to be like 90% of the work. Publishing your base search is just once you've gotten all of your data analyzed, sorted out, and figured out, you've identified the most important, 10, 15, 20 fields in your data, they're all normalized and clean, you're just going to save that somewhere so that people can, use it easily. And then you just reuse that base search in all of your analytics, right? So you'll have maybe the first 10 lines of a search are all the same across an entire dashboard, and it's the last 3 lines where you want to slice and dice things differently that get changed into an analytic product. Oh, that last bullet point is important too. If If you have these base searches published, then you aren't the only one that has to do all of the data analytic work, right? People don't have to come to you and say, Mary, I need a dashboard with some like pie charts and bar charts on it. You can be like, here's your base search, go build your own dashboard. I'm super busy with this other stuff. So that's one of the other things where if you get the data preparation and the base search done, you can outsource the analytic to the people who own that, because no matter what, as soon as you publish a dashboard, people are like, oh, that's great, but now could I see it by, and then they want to split your data by another dimension. If they can do that part on their own, then the analytics is more democratized. So this is the method, and we'll go into each of these more deeply, but under the data preparation stage, first you want to remove all your noise. There's two main pieces of that. There's some Splunk noise, just some like metadata stuff that Splunk injects in there, and you don't need that for analytics, so you want to remove that. There's also event noise. There's always extra fields you don't really need, they're not helpful, or there's duplicates, or if you've got an app installed, you might have the original fields and then the parsed sim fields. So you just want to get rid of the noise, and I found that's really helpful for me, because if you're like looking in a pile of dirty laundry, you can like pull the things you don't want and throw them in the corner, and eventually you have only the stuff you do, or maybe clean laundry, right? You have only the stuff you do want. So that's kind of what we're doing here. And then once you've got the fields you do want, you want to start to normalize those, right? So it'll be field names you want to normalize, and then also field values. And really just, these are like the most basic commands that you're going to use as soon as you start using Splunk. And that's like 90% of everything you ever need to do anything with, really. Deploying your props.conf, so there's a couple things you could, once you've got your search and all of your data normalized, you can publish that into a configuration file, or you can just save it as a base search, either way. And then your base search, again, 10 to 20 most important fields, and then your analytics. So when I'm getting set up, you want to always run in verbose mode. You can kind of see down in the right-hand corner there. So run your searches in verbose mode. Set a static time range. So you don't want a rolling window, because the data is shifting then underneath you when you're trying to perform your normalization and your analysis. You don't want that to happen. Later on, you'll spot check that. But for now, you want repeatable, reliable things so that when you make a change in your search, you can see the output and you know it wasn't the data that changed, it was your work that did that. Splunk then has the SIM data models. So depending on what I'm working with, in this case, I was using Sysmon. So we'll see when we get to the demo, there's some ransomware data that Splunk publishes that you can play with. I was using the Sysmon ransomware data, so this is going to be endpoint event signatures and intrusion detection data models that I want to map my data to. And then of course always the admin guide too, right? Because there will be things like event type 1. Okay, well what the hell does that mean? So you need the admin guide to translate that for you. You can then build those translations into Splunk, but without the admin guide you won't know. All right, so removing the Splunk noise. So when I get started with a brand new data set, I'm going to assume you already know where your data lives. And by that I mean your index and your source type. Somebody had to ingest the data and put it somewhere. Maybe that was you, so you know where it lives. If you don't, I maybe should have included a slide on how to find that. But let's assume you know the index and the source type for your data. This is like the first line that I throw into any search. I just get rid of my Splunk noise. And then what I do is I start to, well, first we want to focus on fields that are present in 100% of all the events that we're looking at. The reason for that is because, if you do search, let's say action equals star, that'll return all of the events that have action as a field in the event. But if you have 50% of your events, say, don't have the action field in it at all, those events will get completely dropped. And maybe that wasn't exactly intentional, because maybe you were thinking, well, I even want the ones where action is empty. That will get empty ones, but it won't get ones where action doesn't even exist. And sometimes people have a hard time with figuring that out at first. So I'll show you in the UI where you can see, select the fields that are 100% of your data, because those are fields you're going to be guaranteed you can use in your analytics without arbitrarily losing data you didn't mean to. And then I'm just going to table all of those fields out, because I need to see them. I need to see if they're useful or not. And then you see I've got this new fields minus. Oh, and I'll say the dirty laundry pile that we're throwing into the corner of the room, that's fields minus. So fields minus, that first line that we saw in the previous field, that was getting rid of the Splunk noise. And then we have another fields minus here. And I figured out that this was my event noise. Well, how did I figure that out? Well, I had to go look at my data. So you almost have to know your data before you can get to know your data, before you can figure out what to get rid of. But that's why I table it all out, and then I can start to see, oh, I've got a bunch of duplicates. I don't need 15 versions of the same field, so I can throw those out. The other thing also is, it's the same command here, and you're like, okay, well, why did you use 2 different lines for that? It could all just be in one. I like to keep my piles segmented, right, because maybe I have like a black pile of dirty laundry and then like a red pile of dirty laundry and a blue pile, because later I'm like, oh, you know what, let me go look at the red pile again. I can find it more easily this way. I will say there is literally no dirty laundry at my house that isn't black. Oh, gray, I guess. And then once you've identified, so in the previous slide I had the second fields minus, right? Fields minus event channel. Am I sure they're trash? I will usually go back and double check all my work, right? So I flipped the second fields minus to table plus, which then only displays those fields. And then I ran a quick stats values star, and that gives me a quick visualization of all of the distinct values in each of those. So I can say, yeah, for sure, event ID and task duplicates. Keyword, completely useless, because I don't know what it means, and it's the exact same value in every single event, so it's really not giving me any contextual information. I know it's sysmon already, because that's my source type. High cardinality fields, so fields that have like thousands of distinct values, will crash your browser. So stats values star with caution. And then you want to start to identify the important fields here. So you can see now I've got 3 piles of dirty laundry. I've got still my table command, which are the fields that are still important from those ones that are 100% prevalent. And I just wanted to start to work with some of my most important fields. So I just saw, you know, I've got 4 host name fields. Let me look at all of those and figure out what's the difference. Which ones do I want to keep? Which ones do I want to trash? Do they need to be normalized in some way? And I'm just going to use, again, our basic fields table stats, the UI. We're going to find and group fields that have duplicate and similar values, make more trash piles, figure out which ones we want to keep. And people will look at this when I'm working with them, like one-on-one, and we're doing a screen share. They want to tell me, Mary, fields, tables. Don't worry about it, right? We're not actually building a search. We're just doing data analysis right now. So none of that really kind of matters. Don't worry, it's okay. We'll clean it up at the end. Is anybody relatively new to regular expressions? Or are you guys kind of okay with regular expressions? If you're not, this is a really excellent book. It's like a 1/4 inch thick. It's like $15 on Amazon. I think I only read the first half of it. So you can get through like 30 pages and most of the regex you'll need for anything except like regex competitions, perhaps. So then you start to normalize, and you can see right here at the bottom, right, I decided to rename device as dest. And then I also did a regex to extract the destination NT domain, which is just the domain and not the full FQDN. And then I made a new trash pile, right, because I now no longer need computer, device, or host. Those are all duplicates. And then again, I'm going to spot check, right? So where I just invented a new field called destNT host, well, if I know for a fact that that my device field was present in 100% of my data, right? Because that's what I was starting with, 100% of all of my fields. If I perform a regex and then I do where is null, the new field I created, and that field is empty, then my regex is screwed up somehow. Because if I've come from 100%, I should be preserving still 100%. It's also a little bit of art and science. I know that like a sim schema should be, like the sim schema is the sim schema, right? But you know, why did I use dest instead of device? Turns out after I worked with this data set for about 4 days building this talk originally, I ended up not doing this at the end. I went back to the original device and destination. But when day one, I was like, device, I hate device. It's like this weird intermediary thing that isn't exactly clear if it's the source or the destination. But by the time I got to the end, I was like, oh, okay, I understand now with the way that the traffic and the data was working in this data set that I actually needed the intermediary and the two directions. So it's not exactly cut and dry, and everybody's going to do things a little bit differently. Fundamentally, you should come up with the same result at the very end, right? You should, at the end, have roughly the same fields. It's normalized roughly the same. And then you just iterate, right? We walk through all of this again, and then we start to look at fields with 90% coverage and then 50% coverage. Because a lot of times those 100% coverage fields, it's going to be like the host name, the IP, whatever, but it might not really be the real contextual information about what is occurring in that event data. So you almost always have to go down into 90%, probably 50%. Anything less than 50%, you might actually be building a very specific use case as opposed to a more generic like base search that's going to cover your 80%. And then, so here we've got, fields, 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 tables, tables. At the very end, then you clean that up, right? I actually don't need the fields minus anymore because I already know what's trash. I've already figured out now my table command at the bottom. These are all the things that I've normalized and I want to keep. And I've just got my evals and regexes and renames, et cetera, up top. And then this right here. The way I like to do it, when I table out the my very last table command, I'm going to start with my most important fields to the left. So for me, that's always going to be a timestamp, the system generating the event, the type of event, and then the outcome. So in this case, we see the time, the host, the signature ID. So this is sysmon, so it would be like event ID 5. And then I've got the signature, which is the human version of whatever 5 is. Direction, user. These ones at the very end, like command line, file path, I think I was getting all the way down into like the 1% event coverage, but they were still kind of important enough, and I had enough kind of room in my screen to go ahead and add them. I really don't like scrolling left and right. As a bonus, if you're building a dashboard, I really don't like scrolling up and down. I try to get my dashboards to fit on one screen, because people are never going to look at the stuff on the bottom. Maybe like a half a scroll. And then again, I'll validate. And then this is where, this whole time we've been working with a static time range, and that's going to depend on your data set also, right? You might run a search over 7 days and it comes back like that. You might run a search over 15 seconds and it seems to take forever. So things like firewall logs, or I don't know if any of you guys are familiar with Proofpoint, the mail gateway. That stuff has so many logs in it. You can hardly run a 30-second search. But I don't know what, like your AV, you should be able to run 7 days, hopefully, and not have a ton of data, right? So when you spot check, when you've got your base search, you think it's done, expand your time range. or if you've used event sampling to try to make your searches run faster while you're working, remove the sampling so you're getting the full data set. And then you want to check again, right? Are all your regex still working? Are the fields that are supposed to be null, null? Are the fields that are not, etc. And then you can deploy and publish your base search. So I should have had a snip in here, right? Because all the stuff in the middle is missing. But well, if you put it into your props.conf, then you actually wouldn't have all the stuff in the middle, because the system would do all of the work here, right? So from the rename down to the table, that you could put into props.conf file, and then the system would do that for you. I like to actually save them like this, because your more advanced users might actually need to see all, maybe they don't trust you, right? Like I don't trust anybody else, maybe they don't trust me either, and then that way they can see my work. It's also helpful because then if they want to start learning to do this work themselves, they've got some cheat sheet code, right? It's like a private Stack Overflow for them. I gave this talk to a DFIR group in San Diego, and one of the women there, she does this, but what she does is she puts these into the macros. And I was like, oh my God, that's so fucking smart, right? Because then people just know, like, oh, sysmon base search macro, or Palo Alto base search macro. So I thought that was really smart, and I stole it from her. What I would do is just bookmark the hyperlink and be like, here, guys, this bookmark, save these. But then that's where you can actually start to do some analytics, right? Now you've got your base search. So this one here, we can actually craft a command that will, or craft a search that will show us which system was getting ransomware at the time, put in some thresholds, build an alert, and if something like flipped over that alert, which this system would have, and that's sort of how you start to do your detection engineering. Okay, so 4:53. Does that mean I've been talking 23 minutes? Let's do this first. So here are my resources. Now, again, if you go to Splunk, their .conf, the conference Watch Online, this talk is from last year. It is recorded, and they have the PDF of this also. So you can get all these hyperlinks that are clickable if you go there. Otherwise, you can take a picture as well. You can like Google this stuff. Although I made these friendly so you don't see the real URL. But these are clickable if you go get the PDF off of Splunk's online recordings. Again, this whole talk is recorded there as well too, so you can like replay it if you want. So maybe let's do some questions, and then anybody who wants to leave obviously could have left whenever you wanted to. So we could do some questions, and then we can do some demo of some of this if you guys want. Questions? Yes?
So you threw out two thresholds, 90%. Do those come from like statistical analysis of like what is often?
Yeah, so we can show that in the demo for sure.
Okay. Would you ever shift them?
It's built into the UI that way, so.
Yeah, sorry, I'm not familiar with it.
Yeah, no. Okay. Should you guys just want to look at a little bit of a demo? Okay. So, I think it'll just log me in. Oh, no, it won't. Okay. So, this security data set project, it's public, so you just come in here. You see I've used it a lot. This is actually pretty cool. So I don't know if any of you guys are familiar with, Splunk does a Boss of the SOC competition, so it's like a blue team capture the flag. This data set is from their bots version 2. You know what else is really cool? Did I have it on the slide deck? Oh, why did I close my slide deck? That was dumb. do I have? Yes. So you can actually, this is free as well. You just log in, sign up, and you can actually go do the capture the flag on the older versions of the data set. It's pretty cool. Will it take very long to sign in? All my business up on screen share. Okay, here we go. Yeah. Oh, here we go. So, continue. Yeah, so you get the challenge questions and you can go through. So it's really pretty cool, actually. So that's freely available. All right. So this is the actual data set project, and if you pick the boss of the SOC one, it will actually step you through you know, some of the exercises here as well. So we're going to do that. Oops, what happened here? Let's just go to my bookmark. Can you guys see that okay? I guess it's not horrific. Is that a little bit better? You know, I'm off the side here is kind of the thing. I hate to try to mess with it. Oh, it's like super big. We actually do need this side though, more than the other side. Okay, there. That's a little better. Okay, so here I've got my index and my source type, right? And you should pretty much never ever use all time, but I'm going to use it right now only because this is a demo site, and I just want to show you like how I go about, you know, if I'm going to be like iterating this command over and over and over again, I don't want to sit here and wait for it, right? But I need a good representative data set, a good sample of my data to work with, because if I'm, you know, if I'm only working with 5% of my data that's all similar, then all the work I do isn't going to match. But this looks promising, right? Oh wait, I was going to pick that big spike. We'll pick this one. So we can zoom to the selection there. And then this will help us get something that'll run more quickly. And again, I'm running in verbose mode. What that does is that gives me all of these native field extractions here. If we run it, and I'll just show you guys since we have time, right? If we run it in fast mode, which is what they'll tell you in like Splunk trainings, right? Because they already know the data. What they're trying to teach you is how to use the commands. But you don't get all those field extractions out here. Well, if you already know, you know, what fields, then you don't necessarily need them. But that was one of the things that always kind of left me feeling confused when I first started taking the Splunk trainings. I'm like, well, how do you know it's access combined equals 502 or whatever? All right, so verbose mode. This is still kind of running a long time, so I'm just going to zoom in again. And you can see, you know, we've got this static time range here. We're not using a 30-second window or the last 15 minutes, which, right, if we ran it a minute later, it would be a different data set. We'll zoom into this one, and then hopefully this should run pretty quickly. My phone is holding up pretty well. Okay, this looks pretty good. What I'm going to do, I almost never ever use this, but just to get this to run a little more quickly, I'm going to use this event sampling, which will just give us 1 out of every 100 events. So that came pretty fast. Okay, so index source type, we've got verbose mode, we've got our static time range. There's a whole ton of fields over here. So what are the important ones? I don't know. But what we can do, first thing, right, you guys don't actually have to watch me type because I saved all these. Right, here's our Splunk noise. This I could probably type almost by memory really fast, but right? That gets a whole bunch of the noise out of here that we don't need. Perfect. Now what? Now I want to focus on 100% of my field prevalence. So I'm going to go down here to all fields, and you've got this filter here, right? So if we go to all, you can see there's, 0.12%, 100, 67. We'll want to work with these, probably these 30s down here. But let's just flip it to 100%. And this is kind of tedious, but honestly, it's like the best way I've figured out how to do it. I just copy and paste this. Table. And then you do have to go through here and be like, no. No. I won't make you watch. You guys get the point. So there we go. So now why do I do that, right? Because when we table out these fields, now we can start to look and see what's interesting and not interesting, as opposed to this, right, where we've got the event here. We'd have to like click through every one of these and try to, it's just not as workable. But so we table these guys out, right, and we can start to see some things right off the bat. We see we've got, 1, 2, 3 hosts, 4 host names in 2 different formats, event ID and event code, which, are duplicates of each other. Some more stuff over here. Oh, look, we've got, what are these? Event code, event ID, signature ID, and task. So we've got 4 fields that are the same. So we can start to get rid of some of that stuff. But what we need, I won't make you watch me Google it, but let's pretend I have the SIM schema up for endpoint stuff. I happen to know off the top of my head that signature ID and signature are the fields we're going to want to keep, and that task, event ID, and event code are going to be trash. So I just want to start some new trash piles. What did we say? Task, event code, event ID. Oh, and then, what did we say? We said signature and signature ID we want to keep, right? So even though this is going to look like a trash pile, it's not really, but I want to keep it separate. I want to keep it separate so I know that I want to keep it, but I don't want to look at it anymore because I've already seen it and I've assessed that it's good to keep. So I'm going to do fields minus again, but I just know that this is eventually going to turn into my final approved table list. And then we can get rid of this here. What else? We got rid of task, event code, event ID. All right, let's double check though. Event code, event ID. All right, let's see what we got left now. Or let's maybe deal with these host names, I guess. Fields plus, what was it? Computer something, host, device, something. That should give us 4. Yeah, there we go. All right, cool. So you see we've got the FQDN and then the short version. I personally like the short version because it doesn't take up as much real estate, but it's also going to depend on your environment. So if you work in an environment where you've got multiple domains, you might actually need that additional contextual information that includes the domain of the asset. If you're in a single domain, I personally would go with the short version because you know what the domain is. But we're going to go with, we're going to get rid of computer and get rid of host. And I'm going to put them up here. Because they're not Splunk trash, which is right here. This is kind of just like extra event duplicate trash. Computer, host. Okay, so then but do I need 2 fields for this, or do I just want the domain? Like maybe I just keep the host name, maybe I want 2 fields. Maybe I want host name and domain, or maybe I want 1 field that's just the FQDN. I don't know, what do you guys vote for? You want 2 fields? Okay, so I'm gonna do this. All right, this is gonna be, I'm gonna put this right here because these are my 2 lines that I'm eventually gonna be my official work. Eval device nt host equals upper device nt host. Why? I don't know, because I was taught a million years ago that host names are uppercase. I think that's a Windows thing, right? I know we're at a Linux conference, so there we go. All right, very good. And then we need domain, so we're going to do this. Rex field equals device. All right, now how does this go? It goes quote, parenthesis, question, crocodiles, quote, parenthesis, or whatever, parenthesis, quote. So we're going to call this device nt domain, and we want, oh dear, everything after the first dot. So it's going to be oh my gosh, regex live in front of an audience. Whoops, we don't want those. Alphanumeric and dashes, I think. That can go in a host name. Anybody else remember what else? I think that's it. Slash dot.
Can you do reverse, where you do not backslash dot?
Well, I was thinking I was going to start from the end and go up, but I think it's easier if I go from the front and down, because I've got...
No, I'm sorry, I meant inverse searching.
Oh, where it's like knots instead of assertions?
Up caret, backslash dot.
You know, I've got it in my slide deck. I think this will work. Oh, we got to put it in here. There we go. And then I actually I'm sort of neurotic about the order of my commands too. You guys obviously don't have to be this neurotic. But if I'm going to do one upper, I'm going to put the other upper next to it. So eval, actually I want to do it like this. Eval device nt domain equals upper device nt domain. Yay! All right, I'm happy. So now we can get rid of this. We can actually take this out because we're done with the devices, and we can add them to our list here. NT host device NT domain. So you can see here, right, at the very end, this fields minus is going to get turned into a table command, but we can see what we've got is we've started to build our search here, and we just, for our own brains, like kept all of our trash piles and everything else separate. Cool, so now we can see, oh, you know what? So I don't know, I keep talking about Windows logs. I maybe should have picked a different data set thinking I would have to redo the whole talk though. I don't know how many of you work with Windows event logs. This security ID is usually the user account that is performing the activity. So it can be an important account. I think it's like 18 or 19 or 20, I forget which one is like the system admin account, right? But in this particular, so normally I would keep it, but if we take a look, will we crash the browser? Let's try it. That's values. No, we can see here that every single event, so of the 1,600 events that we're working with, now I normally work with a bigger data set than this, are all the same exact security ID. So it's the same user account. What that means is this is actually the account that is running Sysmon, which is collecting the event data. It's not actually an account that's performing the action that Sysmon is collecting the events from. So because of that, it's actually a useless field that I don't need cluttering up my UI. So if this were a different data set, right, if this was still Windows, but it wasn't Sysmon, it wasn't this ransomware, well, forget I said ransomware, if it wasn't Sysmon, right, that would actually be a field we'd probably want to keep. We also see right here we've got 2 timestamp fields. Now when you do a stats value star, oh, and I don't have it in here, underscore time. Underscore time is the field that Splunk uses to mark the timestamp for an event. I didn't have it here in the UI, but I can see right then I don't need these extra time fields, right? So we can put them again up here in the trash. We don't need our, well, we can keep our stats values. So we don't need, so event channel, same as our source type, we can get rid of that. We like the event description. This is actually helpful, although, didn't we see that? You know what, we did see that already, I think. Let's get rid of event channel first. And let's give us back our signature fields. Oh, here they are. So, what's interesting, okay, this is a good example. Does signature have more things, or does it just look longer? Driver load, file create, image, network, oh no, it's the same. It was just longer because it's a shorter field. Okay, great, so we can get rid of event description. That's a duplicate also. And we can put our signatures back up here. Did we got rid of security ID, right? Yeah. I definitely don't care about whatever version Sysmon is running. I'm not the Sysmon administrator, I'm the security somebody. Record ID, I don't know. I don't think it gets me much of anything that I need to worry about it. But you know what? Maybe I do. I don't know. I'm going to make this pile is going to be my pile to go look at later. Like this is my just in case bin. Oh, keywords, useless. Again, it might be something that we want to translate later, but even if this was like a really interesting piece of information, if it's the same piece in literally every single event, which it is because we only have one value, like how valuable can that actually be? You could literally put it as the title of your chart, and then like you don't need that field. We'll save it right here anyway. All right, keywords, where are we at now? Level opcode. Action, good. Direction, good. Process, great. So if we took this down here now, we basically have almost the start of what is interesting about this data. And then basically we just do this again now through, well, we won't do it again, but so what we would do is we'd come over here now and we'd start to look at all the fields with 90%, right? And we can sort this. We know we already looked at the hundreds. Oh, that's all we got here. Okay, so let's go to 50. Here we go. Right, so we would just take now these guys here. Yeah. Right, and work through that again. Eventually, what we get to then is, here's our 90%, right? So we have some signature that we liked, and then all of these guys down here at the end, these are the new 90%ers that we would walk through that same process. What we get eventually is, so here is the actual base search I ended up creating. You can see I did filter some things out, like I don't care about sysmon monitoring Splunk. That's not useful to me as a security person. I mean, I guess maybe if I was monitoring, like, did Splunk get shut down? I figured out this Acronis. I think this is like backup software. Tenable, I don't need that, right? So I've got my index and source type, some data that I just don't need. I've got my renames here, so I named image loaded to the sim normalized. I don't even think this is actually a sim field, but at the very least it's lower snake case. This would drive me completely crazy, like even if image loaded wasn't a sim field, if you left it in camel case down here in the table command with all of the lower snake cases, I would be very sad. So, and then, right, we want to remove our sampling. What I did find out when I was looking at this, do we have it? This one, no. Here, process. If is null app, return process, else return app. Turned out in like the 100 some odd, 200,000 events in this data set, there were 5 that did not have a process field once I was done with all my normalization, and I went and checked every field, right? Every single field, I was like, where is null? And then I looked, oh, it's null. It's not supposed to be there, it's fine, okay? Go look at the next one. Where it's empty, an empty string, is it null? Is there a value there? Does the value match? Is it lowercase? Is it uppercase? Whatever. What I found were 4 events out of like 200,000 that did not have a process. When I looked at them, what it actually was sysmon starting at boot time. So it had the process, but it was in a different field, monitoring itself at boot or something. But that just goes to show like the level of neuroses that I'm at when I'm like validating this kind of thing. So I'm sure nobody else would have cried about those 4 events. All right, so now, should we try to find the system that was triggering that was being ransomware? So we've got, what do we have? Let's do, what time is it? 5:19, 10 minutes. Maybe we can come up with something for ransomware real quick. I think what we want is stats, count, count, yeah, count. Let's do count. Process. Let's see, ransomware. What does it do? It encrypts every file on your system. I think it triggers a unique process for each file when it starts to encrypt them. So I think if we count the process IDs by system, by device. Oh, interesting. I decided not to uppercase this. Weird. See? A little art and a little science. Stats count process ID by device. And let's do also this one, distinct count. ID as DC. As, let's do this. Okay. Fingers crossed. I think we can see which one it's going to be. Can you guys see that all right? Now, oh, you know what? What's the time range on this? Oops. Yeah, 27,000. But if we were going to write a search, what we would want, what do we got here? We're actually looking at a whole 24 hours. We wouldn't want that for an actual search. 4 p.m. We'd want to do like a 1 hour window. Sim to selection. Okay. So if we were going to write a detection alert for a SIM or a SOC, this would, this would be our base search that we would save and give our users, right? And we could reuse this now any number of times for stuff. All we had to do was throw this one line on the bottom, and now we have a ransomware detection or something fishy detection, right? Something that's spawning a shit ton of processes on your system. So in 1 hour, so we could easily put, we don't know if this one is also, like if it's got something fishy going on, it could. 4,000 is kind of high. We could easily do, we wouldn't want to just run this every hour, right? And every hour it would give us this whole list. If you've got 20,000 systems in your environment, every hour you would have this list of 20,000 systems. So we need some kind of a threshold, and then we can set that as an alert so we don't trigger alert fatigue with our SOC. So we would do where PID greater than 1,000. Yeah. 5,000. We need a better data set, or not a better data, a larger data set in order to pick an appropriate threshold. Right now we're just looking at 3 hosts in an environment. You would look in your environment, hopefully you don't have active ransomware going on, and you would be able to see what's normal. There might be like servers, web servers that are really busy, so they might get their own alert because the threshold might need to be 10,000 as normal. But with your user endpoints, the threshold could be 5,000 or whatever, right? Where PID greater than 5,000. And then we don't need, we do, yeah, distinct was not. That's interesting. Yeah. But also, maybe we also need to count, maybe just the process IDs as being lazy. Is it also going to be like well, it wouldn't be the process, but maybe, do we have like the target file? Let's also do that. I'm gonna do, actually, what was it, file path? And then I also want to do this because I want to see values, file, path, as file, path. Okay. Oops. So we've got only, okay, so this is not, file path is not a good indicator of anything either. So maybe PID is the only thing, right? Maybe this isn't the best alert, but I mean, it definitely does, I'll guarantee you that's the host that got ransomware. But you just have to kind of like poke around through it and figure out, like, what does the data have that's interesting that you could use. The thing about security detection engineering, like, nothing is ever like, hey, I'm bad. It's like all normal activity that's just abnormal. And that's the hard part, is figuring out, no matter what search you write, it's it's always kind of like a judgment call. What's the appropriate threshold, right? You don't want to blast your SOC with like 1,000 alerts a day of just trash that they got to look at, but it's inevitable that at least half of the things they do look at, they're going to be like, oh, it's normal, right? And you just can't suppress and whitelist everything. But that's pretty good. There you go. We caught a ransomware. All right, I think that's it. Comments, questions? Oh, wait. Hang on. I forgot one last slide. Lydia's favorite slide. Here we go. There we go.